Hello from Tanima. You're watching this video in my YouTube handle @justtanima_Barbie. Just to let you know, my YouTube venture is totally a personal endeavor as a voluntary virtual social outreach, and it has nothing to do with my profession when engaged with research and teaching in the field of molecular biology and biotechnology in an institution in India. I personally believe that education should be freely accessible to all, and with this in mind, I have initiated a series on cancer biology. This is my 43rd video on cancer biology. The present video intends to discuss on few perspectives of methods in mutagenic mechanisms of classical carcinogens in the topic on environmental exposure and cancer connection. The present video partially discusses the paper entitled Not All Carcinogens Are Directly Mutagenic, a holistic view of the environmental exposure and cancer connection. The DOI of the same has been pasted in the description box. I would also request you to turn on the subtitle or caption button on the screen in case you find difficulty with my deliberation. To keep watching. Carcinogens metals are hypothesized to cause DNA damage by directly binding to DNA and stimulating the production of reactive oxygen species or ROS, while simultaneously inhibiting DNA repair mechanisms. These mechanisms include pathways involved in nucleotide repair, base excision repair, mismatch repair, homologous recombination repair, and non-homologous end joining. In a study involving 140 smelting workers exposed to nickel and 140 age-matched office workers serving as controls, a significant correlation was observed between DNA damage as indicated by levels of 8-hydroxy-2'-deoxyguanosine and nickel exposure. Simultaneously, a negative correlation was observed between the expression levels of DNA repair enzymes and exposure to nickel. In alignment with this, the authors' prior research demonstrated that the ROS-associated SBS18 signature is widely observed in lung tumors of mice subjected to cobalt and nickel exposure. It is noteworthy that certain effects triggered in cells exposed to nickel are subjected to modification as demonstrated by the restoration of histone acetylation after treating nickel-transformed cells with the histone deacetylase inhibitor, trichostatin A or TSA. Cells transformed by nickel and treated by TSA exhibit a loss of growth capability in soft agar, concurrently normalizing their altered gene expression profiles and reverting to a non-transformed growth state. This indicates that nickel may play a role in tumorigenesis through epigenetic mechanisms alongside any direct impact on DNA. So viewers, hope the video could discuss few perspectives of metals in mutagenic mechanisms of classical carcinogens. Please don't forget to like and share the video and also subscribe to my channel. Here I would like to mention that the references that were used for preparing the video have been pasted in the description box, and if you're interested to look into the details, you might check the same. Hope to meet you soon with yet another video on cancer biology. Till then, do take care, keep well, and bye.